Okay, there's one more thing I want to show you about binary heaps. And this is not something that you'll be able to do in the Python API, unfortunately. We got to be a little custom here. So let's say that I added these 6 items to a heap with these priorities. But let's say that I wanted to update one of the priorities in the middle of this. So let's say I wanted to suddenly make Theo's priority 0. How would I do that efficiently? So we're going to actually need to modify the data structure a little bit, because I have no idea where Theo is in the heap. He turns out to be at the end, but how do I know that without checking everything? So what I'm going to need is some kind of dictionary, actually, that converts from data as the key into the index in the tree. So I've actually got to add something to this. In addition to the underlying array, I'm going to add something that I'll call maybe object to index. And that's going to be a dictionary. So here the key is going to be the object, which has to be hashable. So the strings are. But that's one thing you need to be careful about. And then the index is going to be, or the value is going to be the index into the array, where we can find the object. Okay? So now, every time we add something, we also have to specify that its index. So what did I call it again? I called it object to index. So we need to specify that it's object to index of the data. So remember, that's the second entry in the tuple. That should be equal to the length of the array minus 1 after we put this in, right? And the other thing we need to do is every time we do a swap, we need to make sure that we update the indices. So if I swap 2, then I need to update the values of the indices of the data there. So because I'm doing swap in a couple places, it might be helpful if I make this a helper method. Oh, looks like I already did. Okay, so I should just call that helper method there. Self.swap I parent for heap up, and then swap I and child for heap down. But yeah, there's an additional thing I have to do in swap now, which is I need to change the indices that are the values of these two. So here I'll have to say, okay, self dot object to index. Well, let's see. I guess I'll say I priority or I IDX. No, what do I say? I guess I'll say object I is equal to self.array I1, object j is equal to self.array j in the next one. Okay. What I want to do is I want to make the object i's index be j, and I want to make the object j's index be I. Okay, now I think I'm good to go. So, okay, when I swap, I'm updating what the new indices are supposed to be for the 2 that swapped. And then when I add them, I have to initialize. When I push, I have to initialize the index, like that. And so, okay, maybe just to check my work, what I'll do here is I'll also, in parentheses, plot what that index is. So in my draw method, I will, in addition to having this thing in parentheses here, I will also put along the index self.obj to idx of that. All right, so a little bit tedious, but okay, so this tells us Layla's at index 0. Okay, that's 1, 2, got a little cremmed in there, but 3, 4, 5, I can see them. All right, that's good. So now what I need to do is make, actually probably a couple new methods. I'll make one method just to tell me if a particular object is in the tree in the first place. So maybe I'll make a contains method. Now that I have this object to index, I can actually check efficiently using the hash table there. And so I'll just return the object in self.og2idx. So if that happens to be one of the keys in this, then the object's there. So I have that method. So now I can say something like, print, Theo in T. And that's true. But if I print Nick in T, that will be false. Okay. So now before trying to update the priority of something, I should make sure it's actually there. I have that functionality. But yeah, let's now say, in addition to push and pop, I'm going to extend the API. I'm going to extend the ADT here to update. So here, I'm going to pass along the entry, but I will, first I'll make sure it's actually there. So I'm following the same format where the entry is a tuple, whose first element is the priority, whose second element is the object. So if the object, so I should actually assert that entry at index 1 is in my data structure here. Otherwise, it doesn't make sense to update the priority. So I should just throw an error. If you ask me to update the priority that's something that's not there, I should throw an error. But if it is there, okay, let's think about what should I do? Okay, so to get at this, let me unpack the what the new priority is supposed to be and the object from this parameter here. And let me get the index that this object is at, so I can look that up in the new data structure that I'm maintaining to help me quickly go to the index of this thing. And let me also store what the old priority is before I overwrite it. So I say the old priority is the array at this index, element 0, right? That's where we find the priority. And now I can go ahead and I'll overwrite what the old priority is with the new priority. And now I have to think, okay, maybe I just violated the heap condition, right? So I'm changing the priority of this thing in the middle of the heap. And it might not actually satisfy the condition that the children are supposed to be greater than their parent. So let's first look and say, okay, what if the new priority is less than the old priority? Well, in that case, we might need to do a heap up, right? We might need to swap this with its parents because we can't have something less than... so it might be the case if the priority is getting smaller that we suddenly become smaller than one of the parents. It might be okay, but it might not. So what I'll do is I'll just call the method heap up on this index. Another thing that could happen is that the priority is going down. That the priority is going up. So if the priority is getting bigger instead of smaller, what we should do is try heap down, because we might need to do that. Okay, but that's it, actually. Once we have this dictionary to help us out, once we have this hash table to quickly locate the objects in the heap, then we can update their priorities. So let's say that I go and I do what I said I was going to do. I'm going to say t.update. I'll update Theo to be 0. And it doesn't like that. Oh yeah, I need to, okay, I screwed up my code here. I need to, if I go back to update, I need to actually unpack this before I do the assertion to make sure that the thing is actually there. Now it says tuple does not support item assignment. Okay, yes, these are tuples. So I should be careful here. That's just how I represented them. I guess I need to, when I do the updates, I need to actually overwrite. I can't just say, oh, let me change that. I actually have to change the whole thing to be new priority object. All right, so if I jump back down here and look, Theo ended up getting promoted to the top. Let's try a couple more. So let's say that I update Artemis to be, let's say, priority 25. Oop. Okay, so then Artemis moves down there. Let's try to update. Let's try to update Apollo to be, let's say, priority. Yeah, we'll make sure nothing changes. I'll update Apollo to be priority 40. And nothing changes except now this has priority 40. And I guess finally, let me update. Let's say I'll update Celia to have priority -1. Okay, so she ends up there. Great. So we've got this working now, and this is something that you'll use in the lab when we get to Dijkstra's algorithm. Okay, very good. Once again, there's one more thing I need to mention. We're doing this in log n time. That's what we want. So if our hash table is giving us things back in constant time, we can instantly locate the thing that we need to change, and then heap up and heap down or log n time for the reason that we said. So we've added this new method to the ADT for priority queue, and we've implemented it efficiently in log n time with a slight modification to the heap data structure. All right, that's all I got to say.